Hello students, my name is Arun Pathania and I welcome you all to the YourPedia channel. Students, as we all know that the DRDO interviews are just round the corner. So I have prepared this YouTube video in order to discuss some of the questions that are being asked in the interviews. Student, in these interviews, the interviewers start with asking a very simple and easy question, but then keep on raising the level by exploring the subject field further in order to check the depth of your knowledge. But no worries, YourPedia is here to familiarize you with the whole process so that you can better prepare your journey for the upcoming challenge. This video is going to be helpful for the civil engineering students, and the question that we are going to tackle today is, what is RCC? Now you might be thinking that this is a very easy question, but let me go through certain basic points with you, and then at the end of this video I'll ask you a very important question that will be a thought-provoking question, and if you will be able to answer it, then it's a win-win situation. So now what's the question? So what is RCC? So let's just understand each of these terms one by one. So RCC, as we all know, that stands for reinforced cement concrete. So what is concrete? Now concrete is a building material, as we all know that, but what it is made up of, it is a composite material which is formed when we combine the aggregates, both fine and coarse, and we take a binding material and then we add water to it. So when we add water to it, it becomes a wet mix. While being wet, it is plastic in nature and therefore can be poured into any shape of the mold and it will take that particular shape. But on hardening, but on setting, it will become a strong, durable, load-bearing material which can help us, which can be for of various purposes. So that is concrete for you. But why cement word is being added here? Because the binding material that we are using in RCC is cement. Okay, not lime, not gypsum, but cement. Concrete can be made with using all these binding materials, but RCC can only be made by using cement. So cement concrete word has been added. Now why reinforced word has been added? Reinforced term by itself means something or a material that is being added to another material, to another composite, in order to improve its properties, in order to help that particular material to perform its function in a better way. So reinforcement is going to be something which is going to be added to the cement concrete so that this cement concrete can behave in a better way, can perform its functionality in a better way. And that material is generally the steel bars that we have seen. As we see in this particular pictures, this is the cement concrete and these are the steel bars which are being provided as a reinforcement in here. So this whole combination, this whole material will be referred to as reinforced cement concrete or RCC. Okay. But now the question arises that if we are not providing this reinforcement, then what will then it will be called? It will be simple cement concrete, or in technical terms we call it as a plain cement concrete or PCC. Okay. Now the question arises, if concrete is such a useful and versatile material, what is the need of adding reinforcement to it? What function of concrete it is improving by the addition of these steel bars? Now the problem is, the thing is, as we all know that concrete is a material which is brittle in nature. Now when I'll say a material is brittle in nature, that it can take a large amount of compressive stresses, but its tensile strength is very low. So concrete, the compression strength is high, but the tensile strength is about 5 to 10% of its compressive strength. So in this case, when this concrete is used in buildings or various other structures, it is bound to get under tension, it is bound to develop tensile stresses, but it will fail because of those stresses and fail at much lower stresses, at much lower value of load. So it will be uneconomical for us. Why waste so much material? Why waste so much effort in making such a material whose tensile strength is so low? So in order to solve this problem, we provide the reinforcement in it. So how this tension can come in these RCC members? So the very first reason is the direct tensile force, you know. direct tension can occur on a member, this will induce tension in it. Other reason can be bending tension. Usually, beams, when we make beams and the beams will work by acting in flexure, so they will bend, and on bending stresses will be developed, and bending stresses are of both nature. They can be compressive on half of the section and will be tensile on the rest of the section. So from here also tension comes. Now diagonal tension develops when shear is acting or torsion is acting, so that results in diagonal tension. Apart from this, tension can also develop whenever there is increase in temperature and your member is not allowed to expand. In that case also tensile stresses will develop. So all these are the reasons because of which tension might develop in concrete when it is used in a structural, as a structural member, or in a building, or in any other engineering structure. So in that case, it is very, very important, or it becomes essential to provide a material which is going to take that tension, which is going to help the concrete to improve its tensile strength, and that material is the reinforcement. Okay. So next question from here will become, what materials can be used as those reinforcement? So this is very simple. We all know that the most commonly used material that we have seen are the steel rebars. This I have stated even in the beginning of the video, that steel rebars are used as the reinforcement in most of the applications. Now why steel rebar is so widely used, not any other material? So the biggest reason for this is, whenever we are going to use a material inside the concrete, there must be a bond that should develop, or that should keep on existing between the concrete and steel at all times, because otherwise, if there is no bond, a proper bond between both those materials, the materials will behave as individual ones. Okay, so when load will be applied, concrete will deform in some other way and the steel will deform in some other way, and there is no connectivity, there is no bond between them, so they will not act as a single unit, as a same composite. So that is called as strain compatibility. So strain compatibility can only be possible when there is a proper bond. Now mostly we can provide this bond between any two materials. Most of the materials can be bonded together, but the problem is when temperature changes. When temperature changes, every material expands, but the degree of this expansion depends upon or varies from material to material. This we can't change. So we have to choose a material for this purpose, for reinforcement, whose the thermal coefficient of expansion should be closer to the thermal coefficient of expansion of concrete, so that even when the temperature increases and when they expand, the strain compatibility is still maintained, their bond is still maintained. So steel was identified as one of the materials whose alpha value, or the coefficient of thermal expansion, is very close to the alpha value of the concrete. For concrete is about 1 into 10 raised to power minus 5 per degree Celsius. For steel it is about 1.2 into 10 raised to power minus 5 per degree Celsius. Other reason for choosing steel is that steel is equally strong in both compression and tension. So the compressive strength of steel is also very high as compared to concrete, and tensile strength of steel is also very high as compared to concrete. So steel can not only be used as a tensile reinforcement, it can also be used as compression reinforcement. Those who have studied the RCC, then they know that sometimes we use steel as a compression reinforcement when we provide it on the upper compression side in case of your doubly reinforced beams. Even in columns we use steel. So steel should be so the reinforcement material should have both high compressive strength and tensile strength, and steel is such a material. The other reason of using steel is ductile. Okay, ductile material is that it can have a large plastic strain before failure, so it will yield when its yield strength is reached. So it will not fail suddenly, it will give sufficient warning before failure. On the other hand, concrete is a brittle material, it will not give any warning. So by adding steel to the concrete, now we have made a material which is balanced, which will give some warning before failure, so that a building can be so that the people can leave the building in case of failure. So there is a sufficient warning. So by adding a ductile material, it's a win-win situation. Other thing is that steel is easily available, locally available. It's available at every place in our country. and India has high iron ore deposits. So from economy point of view, steel seems as a good option. There are other things also which can be used as a reinforcement, and we are going to study those things. So next question is, what are the other materials which will be used as reinforcement? So the most commonly thing that you must have seen is your asbestos fibers. You must have seen those old asbestos sheets, roof sheets that are used in old railway buildings. So those grey color or white color roof sheets are made up of asbestos cement. Now this is simple your cement mortar that you take cement plus this sand, and you add asbestos fibers in it. Because of the presence of these asbestos fibers, this localized tension is taken care of. So the tensile strength of the whole material, of the whole composite, is increased. So asbestos is a very commonly used material. Apart from that, nowadays we are significantly using the fiber reinforced plastic bars, this FRP bars. As you can see in this picture, these reinforcement are not made up of steel but are the plastic bars, and the fiber reinforced plastic bar, normally we use glass fiber reinforced plastic bars also. We can also use granite rods instead of steel rods. Granite will also have the thermal coefficient very close to that of the concrete, and therefore the bond will be maintained. There will be no issue from that point of view. So this can easily be used. Okay. Next is, so now I have told you about the RCC, what is RCC, why it is being made, and why we need to add reinforcement, what are the materials that we use as an reinforcement. Now there are two questions that I'm going to ask you, that as I have promised earlier in the video, a simple question and one is a bit difficult. The first question that comes to my mind is, we know that RCC is something in which reinforcement is added. We know that when we walk on the road, or when these concrete roads or rigid pavements are being made, there is some steel that we provide in those roads. So those roads should technically be called as the reinforced cement concrete roads or RCC pavements, but we are always referred to them as CC pavements and not RCC pavement. This is my question: why those concrete roads are not considered as RCC pavements, but they are simply referred to as CC pavements? You can think about it. I'll tell you the answer at the end of the video. Now moving on to the next question that I'm going to ask you, that is, RCC is still is good material. We have done some advancement. We have improved the normal cement concrete and we have made RCC from it. But is there a further advancement in this field also? Because RCC must have some limitations also. So what is the latest advancement in this field? So let me tell you, the latest advancement in this field is the pre-stressed concrete. Now pre-stressed concrete, as you can see in this picture, these are the pre-stressed concrete members. Now this is also an RCC member only, because as you can see, there are some steel that is being provided over here for taking the tension, but there is extra steel that is provided at certain zone, at certain specific location in the member. These are special steel. These are called steel tendons. These tendons are tensioned before casting the concrete, or sometimes after casting the concrete, and when these are tensioned, some kind of movements are developed into this beam, and these movement or these stresses are opposite to the stresses or the moments that are going to develop during the application of real loads. So due to the introduction of opposite nature of stresses, we have improved the efficiency of our member, of our material. So this is your pre-stressed concrete, as I can show you with picture. As you can see here, if we using only PCC to make a beam, and when the load will be applied to it, this tension crack will develop and it will reach at the top and the whole material will fail. But what I do, I provided the tensile reinforcement on the bottom side and I converted it into RCC beam. Now when I apply load over it, now the tension cracks will develop, but they will only reach up to the tensile steel. When they will reach over here, now the tension will be be taken by the reinforcement, and these cracks will not propagate further, and the tension failure is avoided. But what happens is when the load is dynamic in nature, especially in case of bridges, where the vehicles are coming one after another, sometimes the load is heavy, sometimes the load is light, there is no definite static loading. So in that case, what happens is sometimes these cracks also develop further. These can go beyond this steel reinforcement, and when these go beyond steel reinforcement, they get widened at the base, and now it is easier for the environmental agencies or atmospheric agencies to attack the concrete and reduce its durability. Okay. So solution to this is your pre-stressed member PSC beam, as you can say. In this, what happens is special steel tendons is used, and these are tensioned below the neutral axis. Because of it, what happens is that now the compressive stresses will be induced in the whole beam, and it will get hogged up. And now when the actual load will be applied on those tensile stresses which are going to develop after the application of load will be cancelled out or balanced by the compressive stresses which we have introduced by the pre-stressing. So and this member there will be no tension crack in this member under the working loads. If the load is increased beyond a particular value, then obviously the tension will develop, but under the working loads, for whatever loads this beam is being designed, there will be no tension crack. So this is more safer, a better option in case of your members which are under the dynamic loading. Okay. So now this I have discussed. Now coming back to my question that I have asked in the middle of the video also, and I told you that I will tell you the answer at the last. So the thing is that why these road pavements still have this steel rebars in them, and they still are called CC pavements, not RCC pavements, is because of the fact that the area of the steel that is being provided in these pavements is less than the minimum area of reinforcement as prescribed in the IS code for RCC members. If you have read IS 456, you must have gone through a clause where the minimum tensile reinforcement is being prescribed, where AST minimum is 0.85 upon Fy into BD. So whenever we work out this formula for the road pavements, the minimum area of steel will come out to be larger than the area of the steel that is being actually provided. Here in roads, the steel is not provided with the primary intention of saving it from the tension. It is provided for providing link between two different pieces of the concrete, because there is going to be some expansion joint in between, and these two units will behave as separate units. So in order to connect them, we usually provide dowel bars or something like that. Sometimes we provide a little bit of steel for taking tension also, for preventing the localized tension, localized cracking, but the area of that steel will be very less. So when the area of steel, as you can see, let me show you, when the area of steel it will be less than the AST minimum, which is given by this formula, this concrete will not be referred to as RCC, it will still be called as your cement concrete. So cement concrete can still have steel rebars and still not be called as RCC. Now I think that is an interesting point, interesting take on this particular subject matter. I hope this video must have proved beneficial for you, and you must have learned something new and interesting today. With best wishes for your upcoming future, I leave you with this information, and I end this video. All the very best. Thank you very much.